All right, so in this section, we're talking about 3.5, the rational functions. And these are our fraction functions. They have these interesting breaks in the graph. The main rules that we went over in the last video are how to find the vertical asymptotes and then how to find the non-vertical asymptotes. These are our guidelines for the graph. A simple example of a rational function is the 1 over x graph. It looks like this. It's one that we just memorized as one of our basic functions, and we've used our shifting rules with it. But now that we're in this whole section about this, we can see more about why it looks like that. It has a vertical asymptote for what makes the denominator equal 0. So here's our denominator. It's just an x. So we set the denominator equal to 0, and it's this vertical break that way. Then second of all, the non-vertical asymptote, we can tell there's a break this way, horizontal asymptote. It's found by comparing the degree. And there's a list of 3 rules. Whenever we compare the degree, either the numerator is less than the denominator, the degree is the same, or the numerator is more than the denominator. Those are the 3 possibilities, either less, same, or more. And again, we're comparing the degree of the numerator, degree of the denominator. Well, if you just have a constant, the constant has a degree of 0. And then in the denominator, it's understood to be 1. So it's a degree of 1. So that means the degree is less in the numerator than the denominator. And we learned that means the break is at y equals 0. And so that's why we have that break right there. And then you can plot some points and see that the graph is kind of just stuck in those guidelines. Another thing we learned on the last video is that vertical breaks are what I would consider brick walls. You never cross a vertical asymptote. So as soon as you know where the vertical breaks are, you can go ahead and write the domain. The domain will just exclude any of these vertical breaks. So you'll put a parenthesis around that and unions of the different sections it creates. Now, not so with the horizontal or the non-vertical breaks. These non-vertical breaks, you can cross one time. You cross one time, if any, and then it doesn't cross back over. And we'll see some examples like that. All right, so we're ready to do some examples. I'll ask you to use your rules, pause the video, and try to do some of these. So we want to find any asymptotes. Let's do y equals 1 over x plus 5. Okay, find any of the vertical and non-vertical asymptotes. So I'll go ahead with this. The vertical asymptote is found at the vertical is always x equals. You set the denominator equal to 0 to find that every time. So it's the line x equals -5. And the non-vertical, or the horizontal in this case, is found by comparing the degree. The degree is less in the numerator. Just like our last example, the degree is 0, degree is 1, so the horizontal asymptote is at 0. We actually could just use our shifting rules on this. It's a shifting of the 1 over x graph. It's moved horizontally back 5 places. So we might just even go from that. All right. How about this one? G of x, or y, equals x squared minus x minus 6 over x plus 1. Find any of the asymptotes for that graph. The vertical asymptote is found by setting the denominator equal to 0. Vertical asymptote, which is the line x equals -1. The non-vertical is found by comparing the degree. This time the numerator is higher degree than the denominator, 2 over 1. So that meets the third rule for the non-vertical. If the numerator is a higher degree than the denominator by 1, then we do this synthetic division. We do this problem by synthetic division. So we're dividing that into that. So we can use the k value would be the opposite sign, -1, and then all the coefficients for what we're dividing. Bring the first term down, multiply and add, multiply, bring that up, and then add, multiply, and then add. The rule says you throw out the remainder, and then this will be the equation of your slanted asymptote. So y equals, that's 1x minus 2. So if we were drawing this graph, and you can use your graphing calculator to do so, we're going to have a vertical break at -1. So you might draw a little guideline there. And also that determines the domain. Right then and there, you can say it's negative infinity up to that -1 with a parenthesis, and then there'll be a graph on this side, some sort of a graph from -1 on over. As far as this other break, it's a slanted or oblique asymptote. It's a line down 2 places with a slope up 1 over 1. It's not part of the graph, so I dotted in. So it sort of makes an X-looking graph. And then I plot some points to see where the graph is in there. Let's take a minute and do that on our graphing calculator. I want to go ahead and demonstrate that for you. So let's type that in. Take a minute, type that in. Y equals the numerator is x squared minus x minus 6 divided by the denominator. And notice I put the denominator also in a parenthesis and then hit graph. And that's what the graph of that should look like. Notice that asymptotes are not listed here. You're to kind of notice that there's a break vertically, something's going on, and then another kind of slanted break in the graph. But to find those equations, you have to do it by hand. You have to use the rules. But you can get a look at how the graph appears and what the domain would be. Always, if you go to table of values, you can tell any errors. That's where your vertical asymptotes are. If there's an error reading, you put something in for x, like x is -1, you get an error reading. That means it's not in the domain. So that's why we have excluded it with a parenthesis. All right, next example. Find all the asymptotes for this example and then sketch the graph. Y equals or f of x equals. So first of all, to find the vertical asymptote, we set the denominator equal to 0. Well, luckily this denominator, even though if it was FOILed together, it would be a quadratic equation, but they've already got it factored for us. So that helps me. Since it's factored, I can simply set each factor equal to 0 by the zero factor property. It says if you got something times something equals 0, then you can set each part. Either one of those could have been 0 to make that true. So we get 2 solutions. Again, because it's a quadratic, we're expecting 2 solutions. So there's 2 vertical breaks in the graph. At -2, there's a vertical break. And then at +1, a vertical break. So we've got 3 sections on this graph. And again, we could go ahead and write the domain. The domain is -infinity up to this -2 where it does not touch it, so it's a parenthesis. Union, in the middle section here, there'll be some sort of graph, either zigzag that way or this way. It might be a U or it might be an upside down U. But I know the graph either has to follow the asymptotes to infinity up or down on both of these. I just don't know if it's this way, which zigzag. So I'd have to plot some points or use my graphing calculator to find out exactly. But I know there's something in there. There's something going on between -2 to 1. So that's in the domain. Then union, there's something happening over here too. There's some sort of graph from 1 to infinity. So the domain has 3 sections. And again, they're based on where these vertical breaks are. Those are where it cannot touch. All right, so we got that. Now we need to find out the other non-vertical, if there be one, non-vertical. Now remember, I just erased that. This, if FOILed together, would be a quadratic. So these have the same degree. We have a rule for that. When you have the same degree, you divide the numbers in front of it. It'll be the line y equals 1 over 1, or just 1. So at y equals 1, there's a horizontal break in the graph, like so. Now, to sketch that graph, we could plot some points. We know that the graph never crosses these vertical ones, but it might cross this non-vertical line. So the rule says you can cross the non-vertical asymptote one time, if any. The way we figure that out, if we cross that or not, is we sort of make a t-table. Think of it as a t-table. We're going to plug in y equals 1, whatever we got for that non-vertical asymptote, there might be an x value that works, and we can plot it and it might cross that. So the way you find out, you take this equation for whatever your non-vertical one was, plug it in for y is all the way over here, and see if there is an x value that corresponds to it. Let's see, I'm going to write it in its foiled together form. That'll help me a little bit. So to work that out, I could think of this y as being 1 over 1. That way I've got a proportion. A fraction equals a fraction. And when you have that, you can cross multiply. The cross products have to be equal. So that gives us 1 times that equals 1 times that. And now we have an equation that we can solve. Notice if it looks like it could be a quadratic, but when I bring the x across, whichever way you bring the x's, they cancel out. So we're left with just x minus 2 equals nothing, 0, which is going to give me x equals 2. So there is a solution. So there is going to be a crossing point at the point 2, 1. Where is 2, 1? Over 2, up 1. I am going to cross that graph at the point 2, 1. Now also you might want to find its x-intercepts, its y-intercept, all of those kind of critical points, and those can be found by just point plotting. Let's plug in x equals 0. That's always a good one, right? That helps us find the y-intercept. So x is 0 would be 0 squared, 0 minus 1, 0 plus 2, or you could have plugged it in that form, equals y. That's 0 over negative 1 times 2, which is 0 over negative 2, just 0. So at 0, 0. That gave me the x-intercept and the y-intercept at the same time. So I can keep point plotting, but I kind of know the graph is stuck in these guidelines. I know where it crosses, it's one place, and then there's no other crossing points. And let me go ahead and type this in our graphing calculator. So do that as well at home. We'll type this in x squared divided by, parenthesis is needed around all of this. I'm going to type it in this form. Either one will work. Just watch your parentheses, that you have a parenthesis around all the denominator. I meant to put plus x minus 2. All right, here's what my graph looks like. And you can see those 3 sections. So there is a section here, a curve in this little area. Let me get this out of the way. In this first area, there's a curve stuck in that little section, following that, getting closer to that, going to infinity and getting closer to that, but never touching or crossing. We know all of the crossing points. In the middle, it wound up being sort of the U, the upside down U looking graph. Again, it gets closer and closer to these, going to infinity below. Then this last section, it's up here in this area, but it dips down just barely. It's hard to even tell it on my graph, but I know it has to because we've got a point there. It goes below and then follows that to infinity, getting closer to that. It has to follow these guidelines, getting closer as it goes to infinity. It may have a little dip out at some point, but it then tacks back on along that and has to follow it to infinity. Okay, let's see. We got time for one more on this video. I'll ask you to try this one. X squared minus 4x minus 5 over 2x squared minus x minus 10. Again, find all the details and sketch the graph of that. So the vertical asymptote is found by setting the denominator equal to 0. Now this time it's not factored for me, so I'm going to have to either solve it with a quadratic formula, A, B, and C of the quadratic formula, or if you want to take time to work on the puzzle of unfoiling it, doing the reverse of the foil. It does factor. Let's see if this works. I think I know what works there. So check that out. If that's foiled together, that is equivalent to that. Then you set each part equal to 0. That gives us 2 vertical breaks at 5 over 2 and at negative 2. We can take that information right now and write out the domain. It just excluding those 2 points where the graph is undefined. For the other asymptote, The non-vertical one is found by comparing the degree. And that means if it's same degree, we have if the top is less rule, if they're the same, and if the top is more rule. We have 3 rules when we compare the degree. Well, here we have the same degree, and the rule says you divide these numbers in front of the leading coefficients. So that's y equals 1 over 2. So now we have all the information to sketch our graph. So we have a break at 5 over 2, which is 2.5. A break at -2. And we know there's going to be stuff in each one of those areas that we have to hunt for. There is a horizontal break at 1/2. And then from there, just like on the last one, you try to find some points, sketch the graph in. Feel free to use your graphing calculator to get an idea on that one as well. And so y equals x squared minus 4x minus 5 for the numerator, all in a parenthesis, divided by denominator in a parenthesis as well, 2x squared minus x and minus 10. And this time it has the 3 sections. You notice the first section over to the left is in this area up here, kind of stuck in that guideline. And it does cross the non-vertical asymptote. We could find that exact point by plugging in y equals 1/2 for this y and figuring out what x value that is if we needed to get that specific. So it zigzags through the middle. And in the last section, we have a curve right there. So 3 sections on that one as well. All right, we'll try some more in the next video.